Good morning, good afternoon, good evening. Welcome to Enhance International's first in a series of webinars with featured partners SCM Blocks and the Supply Chain Risk Management Consortium, addressing the strategic risk paradox with modeling and simulation, focused on building your resilient enterprise. We appreciate your time, taking the time to join today's webinar on building an evolving resilient enterprise, and we hope that your family are healthy and safe. This is the first of a series of webinars that we will be having with Chris and Greg, and this will be addressing the risk paradox. Other next webinars will be talking about reshoring from China, looking at financial health, Altman Z, of a supplier going south, 1 to 3 tiers down, looking at some civil conflict impacts, minerals way down in your supply chain, and then getting into key manufacturing, moving to India, which is a lot of companies are doing, moving from China to India or otherwise, and then chip manufacturing going live in the US. Of course, that's going to have a substantial impact across the globe. So those are our topics of our future webinars of this series. If you have other topics, feel free to enter them in the chat or send us an email at any time. With that, again, we welcome your feedback. Please enter into the chat at any time, questions or comments. We welcome them throughout the webinar, and we'll get to them as quickly as we can. Also, there's a poll EV /Jim DeVries 073 that's been set up for the word cloud exercise. It'll come about halfway through the webinar. My name is Jim DeVries. I am the founder, managing partner of Enhanced International Group. I will be the host of today's webinar. We are featuring two of EIG's partners, the Supply Chain Risk Management Consortium, Greg Schlegel, will be joining us in a minute, and Chris White from SCM Blocks. Chris, a few words of introduction.
Well, I'm sure you'll get to see some of my more professional work as we get into some of this. So I'll use this as a time to talk more personally. And other than work, I enjoy movies. I am a movie buff, but not so much a movie critic like I know all the classics or anything. I just like good, funny movies. I like romantic comedies. I like horror movies. I like just about anything, but really enjoy movies. I'm always quoting. It drives my wife crazy. I'm always quoting from movies, and she's not good at remembering stuff from movies, so it's a constant struggle with us where I'm trying to have conversations about movies, and she doesn't care for them quite to the level that I do. So anyway, enjoy movies.
So you serenaded her with movie one-liners, is what you said.
Exactly, and she gets a little tired of it. Yes, we have had movies. We're on opposite ends of the spectrum. We have had movies where I am rolling in the aisle laughing, and she's leaving. She's like, I can't keep. I'll meet you in the lobby when this is over. And to me, it's just hilarious. And so,
that's great. Okay, great. That's funny. Greg, a few words of introduction. Thanks for joining us.
Boy. Yep, glad to be here. Sorry to be tardy. Founder of the Supply Chain Risk Management Consortium. I've taught at a bunch of universities. I'm trained as a modeler. I'm a certified Jonah TOC, theory of constraints. So pretty passionate about this thread, and glad to be here with you.
Thanks, Greg. And just a few thoughts about myself. For me, I'm really passionate about the worker and enabling the front lines all the way to the C-suite. That's my passion, and I really look at things as an ecosystem. I think we've all been. You guys are trained modelers. I think I'm a modeler over time as I've learned to do that in many different roles over the years. But I love looking at the ecosystem and saying, how do we enable the workforce to unleash the workforce in a way that enables them to do all that they can do. With that, we're going to get started with our deliverables. Our deliverables today are our first, we have the top-ranked strategic risks according to the World Economic Forum, and we'll also reflect on the recent Baltimore Francis Scott Key Bridge collapse. Second, we'll discuss the financial impact of the single sourcing into your bottom line and what that impact is. And then we'll get into Chris's walkthrough the case study, which will be the majority of the webinar, on his first-of-a-kind simulation modeling technique to address long-term strategic risks to enable executive decision-making. And then fourth, we'll get into providing proactive action planning to address strategic risks in the C-suite relatable items. So overall, our goal is to demonstrate that it's possible to model for long-term financial impacts of strategic risk events, providing tangible benefits to make better decisions faster and quicker than your nearest competitor. With that, Greg, a brief overview of
You bet.
your company.
Yeah, you bet. Real quick thumbnail sketch, folks. This is kind of who we are and what we do. The consortium is made up of 32 companies at the moment, 1,700 supply chain professionals, including folks like Jim. Around the globe, we operate in 23 countries. On the right-hand side, we've broken up our approaches in 3 pillars. We do a lot of education around the globe. We do a lot of coaching and consulting in the middle there. And then we have a host of software as a service, cloud-based solutions that are geared specifically to support your supply chain risk and resiliency needs. On the left-hand side, kind of our products, we have 2 certificate courses. One is basic, and they're online, and the other is geared towards public health care. And you receive certificates going quite well. We have 2 online assessment tools. One is supply chain management online readiness assessment. It evaluates your supply chain process maturity and your inherent risk. We're going to talk about that a little bit today. The other is a pure risk 90-day action plan. It evaluates your maturity, your risk appetite, and your culture using AI and ML algorithms. We coach, we consult, and then we have our solution. So that's pretty much who we are and what we do. Chris?
Thanks, Greg.
Yeah, thanks. So our company and our tool is SCM Blocks, Supply Chain Management Blocks. Blocks being a sort of a shout out to Lego. As you can see on the picture in the upper right, what we do are develop models that small models that connect together to create bigger, more complex structures. And we have a very much, Jim, you mentioned the term ecosystem, and that's kind of the approach that we take. We're at the strategic end of the spectrum where we're looking at the ecosystem, the supply chain as a system with a lot of companies in there all trying to do their best, but they're all connected and they interact with each other, and you're somewhat limited sometimes by what other companies are doing in the supply chain. And so it's very interesting to do these kinds of models. We've done a lot for the military, 5 years of development with the military through various small business programs. And now we're commercializing this, bringing this to the market.
Thanks, Chris. Fascinating time to get to where you're at. Congratulations. With that, just a little bit about Enhance International Group. We're a group of passionate experts to guide your transformations. We have over 50 vetted consultants, consulting companies, and software as a service providers focusing on enabling your enterprise. EIG serves as the master integrator to provide you access to the best and brightest company. Synergistically, our team is dedicated to empowering your organization's workforce by leveraging EIG's tenured expertise covering people, process, data, and technology. It's focusing on your ecosystem, your total ecosystem. Just reviewing this slide a bit, you can see the strategy wheel out front and the execution wheel, the sprocket in the back. And as you can see, that one rotation of the strategy is going to result in many, many execution cycles. So SCNR is our strategy and our priority today's webinar, and we're linking simulation to action. So we're really looking more at the strategic side of things today. Very interesting, but it has a huge impact on how well you execute. And so it's going to be a very interesting webinar. We hope you enjoy it. Our agenda today is first, we're going to look at strategic risk challenges from a geopolitical, economic, environmental, societal, and technical perspectives. We'll look at the impact of risk in the bullwhip effect. And then we'll get into the case study that Chris will cover, the relationship modeling. And then we'll get into the recommendations to address the impact of originating strategic risks, and then what we can do now. So that is our agenda today, and we'll get started with the strategic risk challenges. So we're going to start with a case that you may be familiar with, that you hear on the news big time in the U.S. when the Port of Baltimore, when a ship hit one of the largest span bridges in the United States on March 26, 2024 at 1:28 a.m. in the morning. Unfortunately, 6 construction workers perished in this, but this was the Francis Scott Key Bridge that was built in the 1970s, and it's the 3rd largest span bridge in the world of that size. And from that, what happened? Well, this is what happened. It gives you an idea how much volume of cargo was going through that port at that time. These are annual numbers, but 53 million or 52 million tons of foreign cargo, $81 billion in foreign cargo value, 1.3 tons of roll-on and roll-off construction machinery. So construction was a major area. 1.1 million 20-foot equivalent unit containers. That's a lot of containers. About 12 million tons of general cargo, and about 850,000 cars and light trucks. And it is the largest port in the U.S. moving those type of vehicles. And it's the 10th largest port in the U.S. So when that happened, some things frozen. Luckily, the U.S. has a lot of ports up and down the eastern board. And so we were able to address that. So just as some background, we decided to use the SIPOC to kind of look at this, the inputs and outputs of this. SIPOC is supplier inputs, process, outputs, customer. It's a very common basic Lean Six Sigma tool. And what we'll get into is looking at what happened when it all stopped. So this is what stopped. So this is who affected all the inbound shipments coming in. And these numbers come from Jason Miller. He has a blog. If you don't follow his blog, I highly recommend it. He's from Michigan State University. So we thank him for these statistics in here. But it gives you an idea of what's going on here as far as the countries that are affected, the goods on the inputs, autos and light duty trucks, construction machinery, non-ferrous melting and refinery, and agriculture. And some of these were the #1 ports for the U.S. in movement. So a lot of countries affected: Germany, Mexico, Japan, mainly. And then from an outbound perspective of getting things out of here, the states of Wisconsin, Iowa, and Pennsylvania were mostly affected. And again, the outbound shipments were those autos and light duty trucks, coal to Germany, and also things going to Australia, Belgium, and some agriculture going to Australia and Belgium. So this gives you a high level look at what that impact of the Port of Baltimore. I know Greg has some thoughts. Greg?
Yeah, you bet, Jim. My first flush reaction coming from a theory of constraints background is it does demonstrate what we call unintended consequences of a strategic risk. So it's pretty consequential. So Thanks for the background there.
Chris, any thoughts on this?
It definitely, when you say theory of constraints, and I think when we come up to when we start showing the simulation, you'll see how these kinds of approaches where there's flow and movement of goods at a more macro scale, how that comes into play. So this is a great setup for getting into the simulation in a little bit.
All right, thanks, guys. With that, I'm going to turn it over to Greg here.
Yep, you bet, Jim. Before we delve into the strategic risk paradox, which is part and parcel of our discussion today, we wanted to kind of get you grounded on strategic risk. So we thought we'd start here. This is from the World Economic Forum's 2024 risk report. They always do a risk report from Davos every February. This is kind of the global risks ranked by severity over the short term, which is 2 years on the left, and longer term, 10 years on the right. Essentially, what they do, they color code their 5 categories. The 5 categories are always blue for economic, green for environmental issues, orange for geopolitical, red for societal, and purple for technological. So just touch on the top 5 on the top left there over the next 2 years. Misinformation and disinformation, that actually is coming out of AI. That says good AI bots are going to battle bad, evil AI bots. Very interesting. Extreme weather events, that's number 2, that's green. Red is societal polarization. Purple is cyber insecurity, and then the top 5 is interstate armed conflict. So always a good read if you can get your hands on it. It's rather lengthy, but boy, do they go into a deep dive on strategic risks. So with that, we'll share a couple more threads with you. We thought we'd get you grounded and give you some supply chain risk definitions to prep for the rest of the session. This comes from our best-selling book. It's been out there for about 7 years now. First, strategic risks. Definition. They are the risks that are most consequential to an organization's ability to do what? Carry out its business strategy. These tend to look like this. They have a very low frequency of event, but they're very negative in terms of high negative impact to all of us, like Jim talked about with the impact of the Baltimore strike. Tactical risks next. These relate to mainly external issues with your suppliers and your customers. These risks they have a higher frequency of occurrence, but they have a lower financial impact to your organization. And then finally, we have operational risks. These are what we call disproportionate set of supply chain risks, and they're categorized as operational since they include mainly internal processes that you say you control within your supply chain, like quality, computer issues, and so forth. These are called chronic risks. They have a very high frequency of occurrence. They happen every single day in every single shift, yet their negative impact is very, very low. So we wanted to give you a thumbnail sketch of a couple of definitions. Then we'll talk a little bit about the risk management paradox. You may not be familiar with this. This comes out of RIMS, the Risk Insurance Management Society, based here in the United States. They have almost 1 million chief risk officers as members. They did a study back in 2015, 2016, very interesting, and talked to several thousand chief risk officers. What did they do? Well, they gave the chief risk officers up on the top left a set of statistics. They said, here are the basic risk categories: strategic, operational, legal, compliance, and financial reporting. They all agreed. And they said over the last 10 years, essentially the profile of, or the percent of risk failures leading to significant market decline for companies looks like this. And basically it was 86% of all the negative risk failures came from strategic risks. And you can see how it drops precipitously in terms of impact. Then they asked a hard question. How much time as a chief risk officer do you spend on these 4 categories? Take a look. It's like inversely proportional, folks, and that's why we graphed it on the bottom there. You can see that from a strategic risk point of view, 86% of the negative impact comes from this type of risks, yet look at the time we spend on planning and scenario planning for the risk. And then it just gets inversely proportional. So we just wanted to kind of give you what we call the strategic risk management paradox to kind of tee up the discussion for the rest of the day. Back to you, Jim.
Yeah, Greg, it really shows what you can see is what you work on. What you can't see, you don't work on, right? With that, we'll get into the impact of the strategic risk and the bullwhip effect. And the bullwhip effect is defined as the uncertainty caused from distorted information flowing up and down the supply chain. So if we look at it from a demand perspective on the left here side, the wavy line is the customer. So a small little perturbation of the customer demand is going to cause a ripple effect or a much larger impact from at a supplier perspective. Then from us on the right side here, we see on the supplier side, the left side of this graph, the factory can experience a risk event that disrupts the flow of the goods downstream and ultimately to the manufacturer and the customers. So you can see that. So what do you get when you put it together? You get what we call the W recovery. And when you put both demand and supply disruptions onto a graph, which is exactly what all the industry sectors have been wrestling with over these last couple years, with the COVID pandemic is the prime example of this. Those intermittent COVID surges across the world exacerbated these perturbations and will continue and has continued. And we may say we're at the end of it. With what we're coming to now is high inflation, which we predicted 2.5 years ago, Greg, if you go back to those webinars, and we're at that tipping point of trying to bring down supply and demand and find an equilibrium. And growth rate, as now GDP, as you know, has halved itself this year. Very predictable. All the macroeconomic economists predicted this going back last fall, that this is going to happen until things come out and settle out. And so next year will probably be maybe what we call the first year of the new normal in getting us grounded again to where we were pre-pandemic. With that, Greg, do you have any comments, or Chris?
I'll just make a quick comment. We'll actually see some of this in the simulation coming up. That's one of the things that is unique to our modeling and simulation approach in SCM blocks, is that we are able to capture some of this, the structure, the distortions, the delays in the system, being the supply chain, that can cause some of this to happen.
Thanks, Chris. I'm going to turn it over to Greg.
Yep, you bet. Thanks. We wanted to, before we share a day in the life of a supply chain disruption, folks, we like to pose this as a thought. So with that, this is a risk event detection and response graph. On the left-hand side, on the y-axis, is the value of your organization, your street value of your company, money. On the x-axis is time, from 0 on the left to infinity. All right, so let's say if we have the start of a risk event up in the black dot. Which path on this chart would you want your company to follow during the risk event? The red path, the yellow path, or the green path? I won't wait. Of course you would want the green path because it mitigates the loss of shareholder value to your organization during a risk event. However, if you want to follow that green path, you must learn how to do three things. You must learn how to reduce the time and duration of a risk event. You need to learn how to reduce the severity and the slope of the lines that you see on the graph. And you need to learn how to accelerate what we call the TTR, time to recovery, at the end of the event. And so with that, we wanted to just tee that up with you and then talk a little bit about a use case. This is an actual use case. We think it's a compelling reason to act in terms of scenario planning using modeling. And here's what it looks like. On the y-axis is cost, from 0 on the bottom to infinity on the top. On the x-axis, it's always time. All right. And so let's start on the left-hand side. Let's say you have a risk event with a supplier, key supplier. What happens in the next 1 to 4 weeks? We call this next phase the discovery phase. So within 1 to 4 weeks of the risk event emerging, your people will start to work overtime to assess the impact. All right. What are they going to be doing? They're looking at which suppliers are impacted, if it's weather related or a supplier, what parts and raw material are affected. Do I have any alternative sites available? And what is my inventory? How much inventory do I have in-house and on the road and on the water? We call this the discovery phase. And if you look at the squiggle line is accumulated costs to your bottom line. Let's keep moving. The next phase is the response phase. Now we're in 5 to 10 weeks after the risk event. Your people are still working overtime. It's kind of crisis management, all hands on deck. You're trying to compete in the marketplace. You're paying premium pricing for everything. Inventory, if you can find it, capacity, if you need to build more, and freight. That's the response phase. And you can see the cost continues to accumulate. Next phase is what we call downtime. Now it's 10 to 20 weeks after the risk event. Now, if you're manufacturing product, you're looking at turning down production lines. Why? Because you're running out of parts and raw material. You might be on allocation. That's a horrible word in supply chain. You never want to have to voice that. That means that you are going to pick and choose which customers you can fulfill with product and the others have to wait. You're looking at shutdowns, shipment deliveries, and the costs continue to grow. And finally, we have recovery. What are you doing in recovery? Well, you're trying to satisfy your key customers. You're trying to adjust your competitive position, and we call it recovery or not. All right. So with that is a day in the life of a real situation use case. We just wanted to share that with you over time. And the question I have before I give it to Jim is, could your company operate with 20 some weeks of no revenue? Think about that. Turn it back to Jim.
Thanks, Greg. And we'll get on with the next section, which is the relationship of modeling and the impact of a lost supplier case study. And before we get into that, as you're following along, if you can join polev.com/Jim DeVries 073 and type in what kind of risk events you would like modeled. As Chris brings us through this section, we'll come back to this poll and see what you have to say. With that, Chris, it's all yours.
Thank you. I want to bring up another Venn diagram, sort of like the one that Greg had brought up earlier on slide 15, where he talked about strategic, tactical, and operational. And you see that as part of this Venn diagram in the lower left, what I want to look at is this is the intersection of all the things that we're kind of pulling together in this simulation. So you've got this perspective of strategic, tactical, operational, long-term versus short-term. At the top, you've got this strategic risk paradox from slide 16 that Greg talked about, where we spend these very large high impact problems that only occur every once in a while. Some people call them black swan events, but they have a huge impact on the company. And but we don't spend a lot of time looking at them. So now we're in the lower right here, where we're talking about simulation, and it's a certain kind of simulation that's a little different, and I'll discuss how that's different, where it's able to look at some of these long-term strategic risks and issues. And a couple of things interesting here are that it doesn't require data to get started. A lot of the more tactical and operational network optimization tools, discrete event simulation tools require a lot of data. They are very much built on data. The modeling that we do is built on relationships, the interconnections among all these elements or companies or entities that are in the supply chain. And that intersection of all these three, we're trying to do this in this VUCA world where there's volatility, uncertainty, complexity, ambiguity, all those things. We're trying to understand how can we do any kind of proactive planning or de-risking some of these very large strategic risks over time and mitigate the impact of those. So we're trying to pull all those together. What we're going to do is walk through a simulation. And I want to start with the diagram that's at the bottom. Number one, I know all your eyes are going to that. And then we'll talk about some of the text at the top. But in this simulation, this diagram at the bottom is given a very simple view of what happens within a company in this simulation. That you've got, a company receives some raw materials, it holds those raw materials in some sort of inventory, and we're going to assume they're trying to hold 4 weeks of inventory. That moves into production, a production process, creates finished goods. Excuse me. Those finished goods, we're going to say they're trying to hold 4 weeks of finished goods as well, and then they make deliveries to the customer. So this is kind of the flow of what's happening. And what we're going to look at is an OEM that has a single tier one supplier. So we're going to look at a base case of something simple like 100 orders a week for 2 years. That's what's going to be the baseline scenario. Very simple, very steady state. In these models and simulations, it's often easy to use a steady state, move from one steady state to another and see how long it takes to react and respond and how resilient that system is to make that change from one steady state to another. In real life, we know there's not really steady states, but we have, small oscillations, so they're roughly steady state. In this example, we're only going to consider one SKU, one product that the company is handling. So when it looks financially bad in the simulation, it doesn't mean that that company is going out of business. It means that that product is having issues. And we're also, for just simplicity of the simulation right now, assuming perfect yield. So there's no waste in this. So it's not like for every 100, they lose 10, something like that. If they build 100, they got all 100. So we're also going to look at, when we talk about the raw material and the finished goods as inventories, we're using what we'll say a moderate reaction rate to recovering and filling that gap between what our goal is and where we actually are. So, as a company, I can choose if I'm got a 4 week goal and I'm only sitting at like 2 weeks, I can quickly try to get up to that 4 weeks, or I can slowly close that gap over time to wait to see if there are other adjustments I want to make. So we're taking that moderate, middle of the road approach. We're not trying to go too fast, but we're not going too slow. And like I said, there's 4 weeks of inventory in both the raw material and the finished goods. Now, what makes this approach different, and this kind of ties to theory of constraint, some of the comments that were made earlier, I'm going to use a bathtub analogy. The kind of modeling and simulation we do is what's called stock and flow, or level and rate. So there's an accumulation of something, and then there's flows in and out of that accumulation. So a bathtub is a nice analogy. And so in this bathtub, if you think about it, I cannot snap my fingers and all of a sudden have 100 gallons in the bathtub. The way I get 100 gallons is I open the faucet and I let water come in, I close the drain, and So by controlling the drain and the faucet, I control how much water is in that bathtub over time. It's not immediate. It takes time for these flows to change and adjust and for this water level to increase. So using that example, I want to talk about two things. There's something called static equilibrium. If I turn off the faucet and turn off the drain and I'm holding 100 gallons in that bathtub and I take a picture of that, I see 100 gallons. There's something that we care about called dynamic equilibrium, which is I've got 100 gallons in the tub, but I've got an equal flow rate coming in through the faucet and an equal flow rate going out through the drain, such that I'm always holding 100 gallons. So 5 gallons in, 5 gallons out at any point in time. And so I've got this constant movement through there. But yet if I take a picture, I still see 100 gallons. So the pictures of the two of them together look the same, but they are vastly different. One is static, nothing's moving. One is dynamic, things are changing over time. It just so happens to be in equilibrium. So that kind of differentiates. There's a lot more to it than that, but for this example, that's enough to sort of show. So I want to walk through a couple of scenarios that we're going to look at. The baseline, of course, I mentioned 100 orders a week for 2 years. So that's it, just a nice steady state. We're going to see straight lines, just like that bathtub, straight lines going. That's fantastic. The first scenario we're going to look at after that, we'll just call it scenario 1. It's the same as the baseline. And in that baseline, by the way, there's an OEM and a tier 1 supplier. Okay, forgot to mention that. OEM, tier 1 supplier, one tier 1 supplier. In scenario 1, that single tier 1 supplier suffers a disruption in week 24, so roughly 6 months into the simulation, and it can't overcome that as far as anyone can tell. And so the OEM is just trying its best to stay alive with whatever inventory is remaining. So that's scenario 1. We got a slightly different version of that we're going to call scenario 1A, which is the same as scenario 1. I've got my tier 1 supplier goes out or suffers a disruption and is offline, out of commission for the rest of the simulation. But, excuse me, we're going to bring on another supplier. We know that first supplier is out. So we're going to start from scratch and bring on another supplier. It takes about 4 months to set up, to go look for suppliers, find those suppliers, set up arrangements with those suppliers, all that, and move on to getting that supplier on and let them start building production to get up. So we're going to look at that. And then the last scenario we'll look at, called scenario 2, where from the beginning, I had 2 suppliers. I had 2 tier 1 suppliers. One is doing 60% of the orders and the other's 40%. So I've got an OEM that has 2 tier 1 suppliers. And now when the tier 1, the one that represents the 40%, has a disruption, all those orders move over to the tier 2, and we see a little bit of an adjustment, but you've already got a supplier on, and it's just building capacity at that supplier. So that's what we're looking at. Now, the graphs you're going to see are all the same graphs for the OEM. So we're not showing anything for the tier 1 suppliers. I want to emphasize that. So you're only looking at things that happen at the OEM. So if we look at a picture of this, this is kind of like this is what the OEM should look like. Using that bathtub analogy, if I'm trying to deliver 100, then I should have 100 moving through receiving, 100 moving through production at any point in time, 100 deliveries. And if I want 4 weeks of inventory, 4 times 100 is 400. So I have 400 in raw material and 400 in finished goods. And that's our dynamic equilibrium, 100 flowing through, but our inventories are sitting at 400. So if we now kind of back up and we look at the OEM, is just like what we walked through. And the supplier, the tier 1 supplier, the single tier 1 supplier, looks the same also, because they're supposed to handle all 100% of the business or 100% of the orders or the supply, the raw materials for that OEM. So this is what our model looks like in essence. Got an OEM and got a supplier. Bathtub, I got 100 flowing through, 400 in each of my inventories, and that's what we're dealing with. So if we look at the results from that, we're going to see a lot of straight lines. We're going to see the raw materials and the finished goods just sit there at 400 for the whole simulation. In our deliveries, we're delivering 100 a week, so they're going to sit there at 100 through that simulation. Very simple. This is what we expect to see. We're going to start to build a table of some results just for comparison. So these are at the end of the simulation after 2 years, 104 weeks. And In this table, we're going to look at your cash available. So they're building up the cash, their bank account, cash available. And in this case, the baseline, they end up with $120,000, a little over $120,000 over the 2 years from that one item, that one SKU. There's 100 orders a week times 104 weeks. So we see 10,400 orders. And in the baseline, we deliver all 10,400 orders. And the minimum profit margin that we have is 20%. So again, we're steady state. So we're always making 20% profit margin on this. And so those are some baseline numbers that we want to look at. If we now begin to look at scenario one, it starts off the same, looks the same, with 100% of the raw material orders from the OEM going to that tier one supplier. Tier one supplier fulfills them all. We're in that bathtub. But now at week 24, supplier one goes offline for a while. And if we look at the results of those graphs, again, this is the OEM we're looking at. You see everything plummet. You see the raw material begin to plummet first because after week 24, it's no longer receiving, the OEM is no longer receiving raw materials from its supplier. So the OEM raw material drops and goes to zero over several weeks. In this case, it's 4 weeks because they have 4 weeks of inventory. And so that buys a little bit of time for, I've still got finished goods. And you'll see deliveries continue past, they're still meeting 100 past where the raw material dips because I still have finished goods. Well, then after a few, 4 weeks again, the finished goods drop off, my deliveries drop off, and I'm sitting here at zero for the rest of the simulation. So after, 8 or 9 weeks, I've got my disruption, I've got 8 or 9 weeks of inventory to help me, and then after that, I'm done and I'm sitting at zero for this SKU. If we come back to that table and we start to look at the comparisons, we got some bad red numbers now. We didn't make much. We lost money, in fact, so we didn't make any money. We lost money, $140,000 difference from our baseline scenario. We still had all the orders coming in, 10,400, but we were only able to make it those first up to week 24 plus another 8 or 9 weeks after that gets us to week 35. We were only able to make 35 weeks worth, so 3,500. Our minimum profit margin, so the lowest we ever went, is really negative infinity because we aren't able to do anything and we're holding all this inventory. So we're holding all these costs and we're not making money. So horrible situation. So negative infinity, we'll just say. So now let's look at scenario 1A. So this is the same as scenario 1. We lose our main supplier, but we're going to bring on a second supplier with a 4-month or 16-week delay to do all the paperwork, select them, do all the paperwork, get them up and going, and then they're going to build capacity. So this is what this looks like. I'm moving from supplier 1 to supplier 2. And if we look at the charts for that, we look at, again, the OEM, the first half of this chart looks very much like what we just saw. Raw material drops off. I continue deliveries for a little while. Then my finished goods drop off, and then I'm sitting at zero. Well, I'm sitting at zero for this 16-week period while I bring on another supplier. And now you can start to see everything begin to increase. I'm starting to build raw material. I'm starting to get finished goods. I'm starting to get deliveries now. And then I get up, and you'll notice we get up to 200, not the 100 that's being ordered, because we have all this backlog. So for a while, we overshoot, and we're doing extra to make up for all that we missed. And there's where we see the raw materials kind of really peak, but they're starting to come down. You see the finished goods, the red line begins to level out at 400. The deliveries, the green dash line at the bottom, begins to level out at 100. So we're getting our equilibrium. We're getting back to our new level of equilibrium. Raw material, you can see, will settle down a little bit. And now if we look at the chart, the table, and the results associated with that, the cash available is a little better. We're not in the red because we were able to get another supplier and get things on. This is not including the actual cost of bringing that supplier on. There could be some cost there. We're just simply talking about the flow of goods and the sale of goods here. There's still the 10,400 orders, and we're actually able to make all 10,400. Now, it wasn't a steady state. It dropped, and then we overshot for a while, and then we sort of settled back down, but we were still able to meet them. We did suffer profit margin losses, but negative 1,000%, but it's not negative infinity. We weren't sort of shutting that line down. We just suffered badly for a while, but you can see we still made money in the end, and we met the customer deliveries in the end. So now let's look at scenario 2. So we saw that baseline scenario 1 was bad, scenario 1A a little bit better, but not great. Now let's look at scenario 2. Scenario 2 was if we had from the beginning two suppliers, two tier 1 suppliers, supplier 1 with 40%, supplier 2 with 60%. And so this is now what those charts, the flows look like. At the OEM, I'm still trying to flow at 100 with my inventories at 400, but you'll notice that supplier 1 is actually sitting at 40, 160, a flow of 40 through there, and 160 with the raw materials and finished goods, and 240 for the other supplier. When the supplier 1 goes out of or suffers the disruption and goes to zero, everything shifts over to supplier 2. So there's going to be a period of adjustment, but supplier 2 is already online, so we're not suffering the 4-month gap. They just need to ramp up a little bit. So these are what the results look like for the OEM. We see, again, the left as we come in from the left, everything's steady state. The blue line is our raw material. We see that drop because we're in that period where supplier 1 went out, so we lost 40% of our raw materials. So we dip, but supplier 2 is now increasing their production capacity to meet us. And so we see some of that bullwhip effect that Greg talked about earlier, where we're coming up. And you can see those peaks on the blue raw material are starting to go down. So I'm starting to settle down a little bit. You'll notice deliveries at the bottom stay flat. I'm able to deliver all the time, and that's because finished goods, the red line, you'll notice we stay at 400, and because we never ran out of raw materials, that blue line never goes to zero. We're always able to maintain finished goods, and we suffer a little dip in our finished goods inventory, but not significant. And so as far as the external customer is concerned, there's no impact. They didn't see anything. Their deliveries weren't impacted at all, and that's because we had all this. We had the finished goods. We had a supplier online already, and all we did was shift to build capacity. So now let's see what that table looks like with this scenario 2. And you'll notice cash available, roughly the same, not exactly, slightly lower, but roughly the 120,000. They were similar to scenario 1A, able to meet all the orders, 10,400 orders and delivered. But you'll notice the minimum profit margin only goes to -5%. We were only hit for a little while when we had probably that period where we had that excess raw material coming in, and we're still only delivering 100 at the time. And so that's probably the period where we hit that. So now I want to lay these all out. I want to lay out the raw material, the finished goods, all that on the same chart for all scenarios. So here we are with the raw material for the OEM for the 4 scenarios. So we had the baseline, straight line across in the middle at 400. So my raw material, 4 weeks, remember we're ordering 100. I'm always staying at 400. Scenario 1 dips and goes to zero and stays at zero because I didn't have a supplier that could give me anything. Scenario 1A is the sort of dotted black line that says I'm going to dip to zero, but I bring another supplier on. I finally start getting raw material. I overshoot a little bit, but I'm going to settle back down. And then you've got scenario 2, the green dashed line, and we do suffer a dip. We never go to zero because remember that supplier was already doing 60%, so we never go to zero. And then they increase their capacity. And so we have this little bit of a bullwhip where we're adjusting. The raw materials are kind of going back and forth for a while as they begin to settle down. So that's a comparison of all the raw materials. If we now do a comparison of all the finished goods, we see something similar. We see a flat line for baseline. That's our bathtub analogy. We're meeting everything. Scenario 1 drops to zero, just like the raw material. Scenario 1A drops to zero, but we bring the supplier on, so we start to build back up and get to where we're now, by the end of the 2 years, we're back at that level 400, that bathtub again, smooth. In scenario 2, we suffer a little bit of a dip in the middle, but not significant, maybe from 400 down to 350, so from 4 weeks down to 3.5 weeks, not too bad, and then we're back up and running. If we then take a look at, we're continuing, so raw material, finished goods, now deliveries. So this is what matters to the customer. The baseline, like all those others, straight line across 100. Scenario 1 dips and goes to 0 for the rest of the simulation. Scenario 1A dips and goes to 0, but then we're going to make up for back orders, and so we're going to send extra for a while, and then once we meet that extra, we're going to sell ourselves back down and be back at the 100 steady state. And scenario 2, you'll notice, never suffered, just like the baseline. I always had enough inventory, and the external customer never saw an impact, and I'm flat straight across. So it's very interesting to see all these compared. But now let's look at profit margin, because that's where, now money kind of comes into it. And this is just a crazy chart, but let's walk through it. 20% on the left here, 20%, that's what the steady state is. That was our baseline. We stay at 20% the whole time across. Scenario 1 drops to negative infinity, and that's that green line. You never see it again. It just hits that chart, goes down, keeps going down, because we just have costs and we have nothing to sell. Scenario 1A does dip well below what we see on this chart, but now comes back up for a while, and then maybe it dips again, not as bad, but that's because that raw material is fluctuating. So at times we have a lot of raw material hitting our pocketbook, and then at times we don't. So we're going to see that profit margin oscillate a little bit and get us back. But notice we were able to sell everything. So even though the profit margin may not look good, we're actually still selling and making money. And then you've got the scenario 2, which is that green zigzag line. And the worst it is that first overshoot of raw material, and it drops to -5, and that's the worst. And then at times it's even higher than the 20%, but now it's going to oscillate around there. And you can see those oscillations are getting smaller and will eventually be at the same 20% that we had before. If we look at the cash now, the cash available, the funds available, that baseline was, we started at 100,000. That baseline just kind of kept going up, got us to 120. The scenario 1 shot down, took us down to -20. So we had money to start with, and now we're in the tank 20,000. Scenario 1A, do a little bit better. We didn't lose as much, and over time that would come back a little bit. And then scenario 2 pretty much follows the baseline, a little bit of wiggles around it, but pretty much follows the baseline and works for us. So the last thing I want to show with regard to this is that flow through the bathtub. That bathtub I've got raw material inventory that I'm going to see in finished goods and I'm going to see in delivery. And so you see in raw material a lot of oscillations. There's a lot of craziness. If we look at finished goods, that craziness dies just a little bit, and we see some movement, but really not much, not near as much as we saw with the raw material, because we've got some buffer, that production in between. And if we look at now deliveries, we see, of course, the ones that we ran out of when we lost the supplier and weren't able to recover. We never recovered there. Scenario 1 is a bit of an overshoot we talked about, but here's now the last thing that the customer sees. And so really not, when you look at scenario 2, not much of a zero impact altogether. So those are the simulations and just kind of a good strategic risk analysis of something that's very real. I could lose a customer, be it geopolitical issues, be it an earthquake in Taiwan, be it that I've got some shipping channel that has now closed to me, and that's the only one that was available. A lot of reasons, financial instability, a lot of reasons we can lose somebody. So as we start to look at this from a strategic standpoint, relying on a single supplier, as you saw in those simulations, can be disastrous. In this case, we drop to 0, or we have this massive, this long stand-up time where we got to get another supplier going, and that costs us money and all that. And so we're not able to deliver, we're not able to make all our orders, all that. So relying on a single supplier can be very disastrous. What we wanted to show here, in the purpose of showing this simulation, is to show that strategic risks and issues can be analyzed and modeled and simulated with really little or no actual data. So we had 100 going through and a 4-week desired inventory, but that could have been 1,000 going through, a 2-week inventory. All those could have been could have varied, but we would see relative some of the same changes. We would see raw material increase 50% or whatever it would do. And so the actual numbers themselves, the detailed data didn't really matter for all our learning to occur and to get some of these insights. Now, I'm not saying data is not important or not needed. Data helps you refine and calibrate that model to get you into numbers that you care about. But from a learning and a dynamic standpoint, we learn a lot without even having to get actual data. We can explore possible solutions and just do all this what if scenarios before something even happens. We can just check everyone in the supply chain. What if they went out of business, and let's, how does that impact us? And so we get to where we can do this. Then one thing with the strategic risk is that they play out over a much longer period of time, months and years, perhaps even decades, depending on what industry you're in. The optimization, the discrete event tools that are used to do network optimization, network design, are only capable of doing short-term analysis. They're not built, the technology itself is not made to look at things over months and years when you're running on the order of seconds. This simulation approach that we're using is built for months and years. It's not built for trying to do days and weeks, so you've got different technologies for different ends of the spectrum there. The last point in all of this is that the supply chain is a system, and that no company is an island within there, and no company operates by itself, and even on a larger scale, no supply chain operates by itself, because even within supply chains in the same industry, you have overlap. You have tier 2, tier 4, tier 5 that are feeding multiple competitors, and so you have that overlap. And the key is that just optimizing yourself is often rather, it's helpful, but can sometimes be futile depending on what the situation is, because the decisions and actions at your company are completely dependent on what's happening with other companies in the supply chain. So just wanted to kind of cap that off, talk through the simulation, and sort of give some learning points at the end there, Jim.
Yeah, thanks, Chris. We have a couple questions in the chat. Andre asked if he's found that a single supply chain sourcing is at times a strategic decision. Why do folks do that? Economies of scale and higher quantity. Your thoughts?
Yeah, there are many reasons why you might go with just a single supplier. It very well could be possible that that is the only supplier in the world doing what you need. In that case, you're kind of limited, but that doesn't prevent you from understanding that that's a risk, and I need to go find others, or I need to develop that capability. So let's take that one off the table. But because generally we sole source based on quantities, based on getting lower unit price, and we're letting the cost drive our choice of supplier, not some of these other strategic risks or potential issues that may arise. And now we're seeing that, of course, thanks to COVID and the Red Sea, Suez Canal, Panama Canal, the Francis Scott Key Bridge, we're seeing some of that our supply chains, because we've been very cost focused, are very brittle when it comes to massive changes. They aren't flexible, they aren't adaptable, and that's an issue.
I just add to that. I think you single source, if you're single sourcing a commodity, that's really not a good idea. But if you're single sourcing because of IP constraints, then that's a different dilemma, and there are alternatives to deal with those type of situations also, so that you're not dependent on a single location with that particular supplier. You can possibly help them set up another facility, or you can help another company come up with something different. There are other alternatives to that situation. But when IP, high-tech parts are concerned, you sometimes find yourself kind of in a dilemma. And then there's some materials, raw materials, that are only found in certain parts of the world, and only very few foundries. And especially in the metallurgy area, there's less and less alternatives for foundries around the world. And a lot of those alternatives have dissipated over the last couple decades. Greg, your thoughts?
Yeah, good dialogue, Andrea. Thanks. You're right. We tend to do that in terms of single source for what? delivery, price, cost. In risk management, it's not price and cost and what you buy. It's now, where is the supplier? From a global supply chain point of view, you need to start looking hard at where is that supplier that is supplying 40% of my key raw materials for a major profit product line, and how subject are they to geopolitical weather? That's the key to risk management. Where is the supplier? And how do you feel about that?
And Greg, and Greg, to add on to that is now you can see with different kind of simulation approach than the discrete event or the optimization. There are ways to now look at those situations and run thousands of analyses to say, what if this guy goes out? What if this guy goes out? Or with this company or this company or this happens? And just play around and do all the what if scenarios so that you, before something happens, you already know the hot spots in your supply chain. You already know the vulnerabilities and the weak spots even before something happens.
So thank you for entering in the word cloud here. Some really good ideas here that we will take home with us as we move forward and develop new scenarios. Obviously, batteries and EVs are becoming a big top issue out there, and lithium. So thank you for sharing those. With that, we want to close it out here on some takeaways. Chris?
Yeah. So, we said from the very beginning is, okay, well, this, hopefully people find this interesting, and all right, what do we do? Well, the first thing is kind of walking through some steps is map the supply chain end to end. And I want to give a slightly different definition of end to end right here. End to end in the typical view right now means perhaps from my tier one supplier to my distribution center to my customer, and I may track an order going, I send a purchase order to this supplier, they send something to my distribution center, I see my customer get it, I see my invoice, I pay that invoice, and that's end to end. And I kind of call that side to side. I want to emphasize here, end to end is top to bottom, where we dig tiers into the supply chain, down tier one, tier two, tier three, tier four, tier N, and you build that. And if you don't know what that looks like, which a lot of companies don't, the bill of material for your product that you're making, the supply chain 90% of the time mirrors that bill of material. So if you have components going in to make a system that goes into other systems and a final assembly, I guarantee there are probably suppliers that make those components, and there are other suppliers that make these systems, and there's other suppliers that assemble them. And so if you know what your bill of material is, your supply chain, it's an easy starting point to start with a supply chain that looks like you're a breakout of your bill of material. So then you want to start thinking about what are all the strategic risks and issues that we might look at. And having a computer simulation of this means you can run hundreds, thousands of simulations, and it's very easy. And the simulation doesn't care what kind of disruption or why that disruption occurred, but that's where we come in with intelligence and say, this supplier over here may get shut down because of child labor laws and we don't want to use them anymore, or there's geopolitical conflict over there, or whatever the case may be. So then once you do that, you've got the setting for creating this simulation that'll show you top to bottom. Now in our simulation, we only went OEM to tier one supplier, but a lot of the simulations we do go much, much deeper, and we see some of these same dynamics happening at tier 2, 3, 4, 7, 10, depends on how deep your supply chain is. Very interesting. And it requires, for this strategic long-term capability, it requires a continuous modeling approach, which is what we use. Think of that bathtub flowing, that dynamic equilibrium. Network optimization are very, very specific. That's why it's a discrete event. These discrete events are happening, and those are insufficient for building these long-term strategic views of the supply chain. So you got to use those in tandem. You got to have a strategic tool and a more tactical operational tool. And now what you can do is basically, since you're running all these simulations, you can figure out the best things to do in certain situations. And so you have almost a playbook that says, as I see this happening, I already know how I want to respond. Let me start that right now and get going way back to the slide that Greg showed, where the response response to the disruption or the response to the risk, if the more you delay, you can't recover that, and it just makes it worse, and it kicks off all this. So the faster you can react, the less the impact, and the more you mitigate it. And so that's what you do. You basically build a playbook. If I see X, I'm going to do A. If I see Y, I'm going to do B. And you just watch for when those situations begin to look like they're occurring, and you can implement those playbooks.
So, Chris, we have a question to say, in your modeling, can you make it sensitive enough to be able to model any price fluctuation for having multiple suppliers, like
Sure.
commodity prices
Yeah.
going up and down and
Yeah.
competition?
Yeah, and that's where continuous helps. Is you see those prices kind of, you rarely see going from $100 to $1. You don't see things. It's more this adjustment of 100 down to 97, down to 93 or something like that. And that's where the continuous nature is really good. And those would all play in. That's where all these feedback loops and this kind of modeling and simulation is very helpful, because now as those prices change, maybe I want to hold less inventory. Maybe I want to do this. And so instead of holding 4 weeks of inventory, I'm only going to hold 3. Well, now that makes me a little more brittle and less flexible if something major happens. And so you get all those trade-offs. Most importantly is there is never a single silver bullet solution that works in all cases. It's always
Right.
a set of trade-offs.
Thanks, Chris. And something else that you can do right away in lieu of this is the supply chain management readiness assessment. Greg, you want to give us a quick overview?
Yeah, you bet. Yeah, you can actually start with our supply chain management maturity assessment tool. It has 13 tenets for both manufacturing and service supply chains. We break it out into strategic, which you're looking at right there. There are 3 strategic tenets: leadership, balance scorecard, and intentional redundancies. Then we have 5 tactical tenets within your supply chain. You can take a look at them. And then we have 5 more operational tenets as well. We think, as Chris mentioned, we think these tenets represent a good process of end-to-end supply chain. We have a free tool for manufacturers, which you're looking at there, and then for service organizations like logisticians who don't manufacture product, we supplant number 11, adaptive manufacturing, with supply chain processes. So we'll take a look, give you a little quick picture image of our free supply chain management readiness assessment. The link is the big old red box. What you're looking at is essentially the chart that is the outcome of the assessment. It has 13 tenets. You can see them around the clock, and about 92 questions. And it measures 2 things. It measures your supply chain process maturity and the inherent risk within those processes. So net, the closer that black line is, which is the outcome of your answers to the questions, the closer that line is to the center of the chart, the more mature that process is and the less risk, and vice versa. The farther away you are from the center, the less mature that process might be and the higher the risk. So essentially, we always like to ask the questions, where are you on this supply chain maturity model? What inherent risks do you have in your supply chain? Is your supply chain flexible enough to handle disruptions that we talked about? And so the net on the right is, how mature are your supply chain processes? We think it's a good starting point. Folks, it's free. You can run all kinds of scenarios and maybe have start the dialogue. So with that, I'll turn it to Jim.
Thanks, Greg. And just to close it out, it all comes down to time and money, as we discussed. And so we have some benchmark KPIs here of revenue that is benchmarked with our friends at Gartner, EBITDA, benchmarked with Chainalytics, RONA, return on and by Gartner, and cash flow from Hackett Group. So we chose some metrics there: higher margins, delivery, cost to serve. These are all things that can be gained by doing a simulation and better understanding your strategic risks. These are going to be the improvements that you see if you're moving from being a laggard to an average, or average to followers, or followers to leaders. You can read all those types of gains. But, from return on net assets in the middle, with fewer stockouts than your peers, these are things that it's real tangible that you'll see at the bottom line. You'll see that cash conversion cycle increase or shorten, let's say. Of course, you want to have a negative number of days. That's what you would like to have, is get the cash before you even make it, like exemplars do. So this is an overview of some of the benefits that you would likely see if you embark on a program of understanding your strategic risks and proactively addressing them. With that, I think we're going to close out the webinar. Thank you for hanging in there. We really appreciate it. We did cover a lot of ground here from looking at strategic risks, the financial impact, look at modeling and different modeling techniques in order to drive this, with the first of a kind model by Chris and SCM Blocks. And we appreciate their insights there. And again, modeling strategic event financial impacts within the first 60 days is the most important thing to do. There isn't any tools out there today that can model to this kind of level of sophistication. And of course, we gave a fairly simple scenario. There's much more complex ones that we'll be sharing in the months to come. With that, we want to thank you, and we look forward to you joining our next webinar, where we'll look at reshoring from China. And Chris, do you have any closing comments for us?
No, this has been it's been fun from my side. I like looking at real world examples and showing some of these impacts, because it's often very enlightening to people that have not have only used a spreadsheet at the best, at this level of analysis, trying to do these kinds of things, or have tried to use some of the current tools, the discrete event, the network optimizations, and have found them to be limited and not able to do that. So I think it's very enlightening for folks. And so I'm looking forward to our upcoming ones to show even other examples.
Thank you again, everyone, for joining. Greg, your final comments?
You bet. We hope we provided some helpful hints during the session of addressing what we call strategic risk paradox with modeling and simulation. So the key takeaway for me is how the bullwhip effect can impact your bottom line, and what tactics you can take to perhaps mitigate some of those impacts. So thanks for joining us, and all the best.
Thanks, Greg. And this is my closing thoughts with the company, with the complexity of mitigating strategic risks. They're more visible now than they've ever been. And we now have the opportunity to be proactive in this arena with modeling and simulation. So we encourage you to reach out to Chris and Greg on how we can get ahead of this, so we're not caught flat-footed, so to speak, in dealing with these strategic risks, and how we can make that a competitive advantage over your competitors, because you're able to act quicker and faster than they are. With that, thank you again. All the best.